Hi, good afternoon. These notes are on prime factorization. This should be page 13 in your notebook. So here's just an example of what we will be doing this afternoon. And if you want to decorate the front of your notes, feel free. So first we need to make sure that we understand what is a factor. Well, a factor is whole numbers that are multiplied to find a product. So let's go ahead and do some examples. So what are factors of 14? So what numbers can we multiply by each other to get 14? Well, we know that 1 times 14 gives me 14, and 2 times 7 gives me 14. Now I am going to follow the instructions where it says order them from least to greatest, so let's make a list over here. So 1, 2, 7, and 14. Now we're going to talk about what is a composite number. And in our notes from the other day, we talked that a composite number is a number that has more than 2 factors, one in itself. So let's go ahead and remind ourselves of that. 1 and itself. So it has 1 factor pair, but it has 2 factors. So 1 and itself are the 2 factors, which this is 1 factor pair. So what are factors of 24? Well, let's start from the easy. So 1 times 24. 24 is even, so let's do 2 times 12. And then we also know that we can divide by 3, so 3 times 8. And then we also have 4 times 6. And that's all that we've got. So now that I have my factor pairs, I have 1, 2, 3, 4 factor pairs, I'm going to list all my factors individually from least to greatest. So my smallest is 1, and then 2, 3, 4, 6, 8, and 12. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 factors. So now that we've talked about composite, let's talk about prime. Prime is a number that has exactly 2 factors, one in itself, which we wrote up here. Wait, oh no. Sorry, I made a mistake. Can you cross through this, please? My bad, I'm sorry. This was meant to go down here, so I apologize for that. So what are factors of 53? Well, the only numbers that can divide 53 are 1 in itself. So we're going to list them from least to greatest, which that's kind of easy. So 1 and 53. Okay. Prime factorization is a number written as a product of its prime factors. So if we know what prime means, it means one of those numbers that only has 1 in itself in common for its factors. And if we're breaking down the numbers to its prime factors, then we'll get prime factorization. So that's just where this long fancy word comes from. So let me show you one of the methods, which is the ladder method. And we're going to do it this way. So we take 24, we kind of make like a branch. You might have maybe called it a tree diagram last year. So you try to figure out just 2 factors, any 2 factor pairs that you can think of. You can start small and do 2 and 12, or you can do 4 and 6. It doesn't actually matter which ones you choose. So I'm going to do 4 and 6 just because I like 4 and 6. All right, so let's talk about this. 4 is not prime, neither is 6. So this means that we are not down to our prime factors yet. So we need to keep going till we reach some prime numbers. Well, 4 can be dropped down to be 2 times 2. So 2 times 2 gives me 4. And I know that these are prime, so I'm going to go ahead and circle them because that lets me know that I'm done with that part of the branch. And I'm also going to finish 6 because 6 is still composite. I need to break it down till it's prime. So 2 and 3. All right, so let's try it. So 2 times 2 is 4. 2 times 3 is 6, and 4 times 6 is 24. So these numbers right here, when I multiply them together, gets me back to 24. So if I write it in a string, 2 times 2 times 2 times 3, well, 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So I know that I've done it right, and we're going to now write it in exponential form like you learned from Unit 1. 2 times 2 times 2 can be rewritten as 2 to the third power, because we have 3 2's multiplying themselves, and then times 3. You can write to the first power, but it's not necessary. Okay, let's try another one. So 144. Well, I know that 12 and 12 can go into 144, but what if I didn't know that fact? I do know it's even, so let's try even. So 2, and then I do some division maybe over to the side, and I figure out that that's 72. Well, I look at my factor pairs, and I say, all right, well, let me circle the 2 because that's prime, but I can't circle 72 because that's still composite. So now I'm going to break down 72. All right, let's pretend I didn't know my factors of 72. I still know it's even, so I can go ahead and divide by 2. Well, 2 goes into 72 36 times. 36 is composite, so I'm going to keep breaking that one down. All right, now 36, I know my factors, so 6 and 6. Now again, if you know your bigger factors of numbers, go and use the bigger ones first because they break down a little faster. But if you ever get stuck, just go with the easier, smaller numbers. All right, so now we have 6 and 6. 6 is composite, so I still need to break it down. So that's 2 and 3. And 6 is 2 and 3. So now I look at all of my prime factors, so 2, 2, 2, 3, 2, and 3. I'm going to write it in a string. I'm going to do it down here. So I'm going to put mine in order. So 2 times 2 times 2 times 2. So there's 1, 2, 3, 4 2's, and then 3 times 3. So let me count them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 4 2's. 1, 2, 3, 4, and I have 2 3's. I'm going to write this in exponential form. So this would be 2 to the 4th power times 3 to the 2nd power. Okay, let's move on to the next number, 66. So for 66, I can do 2 and 33, or we know our 11's facts. So we know that this is actually 11 and 6. Well, what do we know about 11? That 11 is prime. So let's go ahead and circle 11. And we get prime. And then 6 is composite, so we have to keep breaking it down. 6 is 2 times 3. And then we are finished because we have now broken down every branch to its prime. So now we're going to write this in a string in order from least to greatest. So 2 times 3 times 11. And you can check it. 2 times 3 is 6, and 6 times 11 is 66. Well, now we're just going to write it over here. And guess what? We don't have to put any exponents because nobody has an exponent bigger than 1. So we can just leave it as 2 times 3 times 11. All right, and then let's do 36, which we kind of did 36 over here anyways, but we can do it again. All right, let's maybe not do 6 and 6. Maybe let's do 4 and 9, and let's see what happens there. All right, so 4 times 9 gives me 36. So then I can take the 4 and I can break it down. And 2 times 2 gives me 4. And I know that I can circle the 2's because those are prime. And then 9 is 3 times 3. And 3 and 3 are also both prime, so I can circle those. Now I'm going to write them in order. 2 times 2 times 3 times 3. And then I can write that in exponential form. I have 2 2's, so 2 squared, times, I have 2 3's, so 3 squared. And there's my prime factorization of 36. All right, so what you need to do is go over here and practice each of these. Now, I will tell you, if you ever have a number, like for example, if you ever have a number like, let's take 13. Can you actually find the prime factorization of 13? Not really, because it's just the only two factors of 13 are 1 and 13, so there is no prime factorization. So it really is just itself. So just an FYI that if you come across one of those over here, that's how you would do it. All right, well, I hope that you enjoy my video. If you have any questions, please comment down at the bottom. If you want to leave any kind of comments as far as anything that I need to fix, just let me know. And then hopefully you will be able to understand this, and I will see you tomorrow in class. All right, have a great afternoon.